Welcome to another tutorial in Ansys Workbench. In this tutorial, we're going to look at the stresses and deflections that develop in the disc brake system of a bicycle. In this image, we can see the spokes in a bike wheel. The disc, called the rotor, rotates with the wheel. When the brakes are applied, fluid flows through the hydraulic line to the caliper. The caliper squeezes on the rotor, slowing down the spinning wheel. We've been given a CAD model of a disc brake system in an IGES format. We will import this file into SpaceClaim and perform a geometry check. When importing CAD files into finite element models, the geometry can contain a lot of detail that isn't needed and really slows the meshing and solution processes down. These details are removed through a process known as defeaturing. We will look at some of the defeaturing tools available in SpaceClaim. We will then bring the model into mechanical and check the contacts, apply a mesh, apply the boundary conditions and loads, and then solve for the stresses and deflections. I hope you enjoy the tutorial. After opening Ansys Workbench, left-click on Static Structural, drag it into the project schematic window over the green box. It'll turn red and let go, and we now have our static structural working window. Engineering data has been checked, and we know that the default is structural steel. Although it is highly unlikely that this entire disk is made out of structural steel, the focus of this tutorial is on CAD import, and so we're just going to let the default of structural steel be used throughout the model. To import the geometry, it's quite easy. All you have to do is click on geometry with the left mouse button, then right click, and then scroll down to import geometry, browse to where the file is, and click on the file and import it. If you look over here at this drop down, you can see all the files that can be brought into SpaceClaim. We have AutoCAD files, we have CATIA files, IGES files, NX files, SolidWorks files, and STEP files. All of those are major software packages that can be brought into SpaceClaim quite easily. The one thing I have found is that you want to make sure that in these CAD packages you create bodies and not surfaces. It's a lot easier to import solid bodies than it is surfaces and then try to expand them. So since our file is an IGES file, we'll click on IGES, click on the file, and click Open. You can see we have a green check by the geometry. However, you are strongly encouraged to go check the geometry and make sure the geometry has been brought in as you think it should be. So double clicking on geometry, we can see that it is starting SpaceClaim. After opening SpaceClaim, we can see that our geometry has been brought in pretty well. I can middle mouse click to rotate the geometry, and wherever the mouse is at the time when I click the middle mouse button, that becomes the rotation point. To look at the geometry straight on, I can come down and click on the x-axis. Coming over to my structure tree, I can see that the geometry has been brought in as components. If I want to not view any of these components, all I need to do is unclick the box. I get a little note here that says to activate or suppress, we need to click that back on. But I can just simply close that box. And you can see that I can delete all the parts and the different geometries to look at what has been brought in. The thing that I need to do is check the geometry, so I can do this all at one time. So I'll left click on the top component number 1, scroll to the bottom and shift left click the bottom, then right click and click on check geometry. And down here it says, it went through that quite quickly, but it says no geometry problems were found, so my geometry is okay. And I could go mesh this and solve it. However, when I look at this geometry, I can see that it's quite complicated and a mesh for this will be pretty complex. And so we go through a process called defeaturing. And defeaturing is the process where you go take out features of the model that might not be important to the stresses that you or deflections that you will be. To begin the defeaturing process in this model, we'll first look at what we can do with the Fill tool. So I can come over here to select, click the drop down and click on using box. I can come over here and I can select a bunch of these circles and you can see that those surfaces have been selected. Then I can come up and click on the Fill tool and it will fill in those holes. It's likely that these holes significantly affect the stresses and the deflections in this disk, so we may or may not want to get rid of them. But again, to do that, select using the box, highlight the circles that you want to fill, and although in this view it's difficult to see that they've been selected, if you rotate your body a little bit, you can see those surfaces have been selected, and then simply click on the Fill tool and it fills those holes. We'll look carefully now at some of the geometry that's going on in these connection points and look at what we can do to simplify those connections. From this view, it's kind of interesting to note that there is not a solid connection between this inner support and the actual disc that the caliper squeezes. If we rotate this around to the back side, we can see that there is a clip ring that holds this connector that goes through the two parts. This is kind of a complicated geometry, and to mesh this would take a lot of elements. So what we can do is zoom in on one of these and begin to start to defeature this structure. To do this, we need to identify some of these components and hide them so it's easier to see what's going on. So I can right click, then scroll down to select component, and I can click on this component and rotate it around so that I get that component. So if I come to select component and then I can see that it's highlighted, I can come over here to find it in the structure tree, and that highlighted component will be the one that I can get rid of to clear up some of the ambiguity. Now I can also do the same thing on this one, so I can select component and click on this component and select component, and it'll come over here and tell me that I now can delete that component or just not show it. It's not actually deleting it. Now that clip ring is pretty complicated. What I can do is I can scroll in and I can go around and click on the select and select several of these surfaces. So I'll begin with this little fillet right here and control click as I go around this entire area, selecting all of the faces that make up this contoured, somewhat complex surface. And I just messed up because I hit click without holding down the control button, and so it starts over. You also need to be careful that you don't get the lines. All we're looking for are the faces. And so this can be a little bit tedious of a process. There are ways to simplify this and do it more quickly, and we will talk about those in a few minutes. So now that I have all of those surfaces selected, I can continue to select these few coming around to this fillet and then click the fill command, and I'll get a partial fill on this, and you can see that I get that fill. Now to come back and do the fill command again, I can click that surface, rotate it, click this surface and click on fill, and it will fill that whole region in. Doing the same thing here, I can click on those faces and click the fill. And now I have a much simpler disc or clip ring that will mesh a lot easier. If I bring back some of these parts, I may be interested in the stresses that exist between these and develop between them, and I may not be. If I am not too concerned about that and they're the same material, I can come and use the combine tool to merge these two bodies into one body. So I could come up to click on combine, then click the first body and control click the second body, and now those bodies have been merged when I come over and click on the select bodies to merge button. Now they will be recognized as the smallest component over here if I want to select that particular component. I can also use the pool tool and the pool command to make regions easier to mesh. So if I come to another new element, I could come here and pick this face, and I can pull this in a radial direction out so that it is the same distance as the other parts. So clicking on that face, I can bring it out and make it the same radial dimension as the outer disk. And now when I merge those, I would have one body that has the same radius. And again, that may be of interest to you in the stresses, and it may affect your results in a way that you don't want it to. There's also some really nice features in selecting in Ansys Space Claim. If I come up here to the select, and then I come over here to the selection tool, I can see that I can pick bodies based on lots of different similarities. So for example, if I have a fillet radius in here, if I come and select this radius right here, I can come over here and click on all rounds equal to 3 millimeters, and when I do that, it would select all of those rounds, and I could come over and click on the fill tool and fill all of those at the same time. So this selection tool is a very handy tool. It lets us do lots of selections of difficult components very quickly. So again, here I could click on this radius here and come over and select this based on the same size, equal radius protrusion. I can pick on same color. I can do all kinds of quick selections over here to help do a much quicker defeaturing of this structure. We're going to go ahead and do minimal defeaturing for the actual structure that we're going to pull into Ansys Mechanical. And so with this structure, we'll go ahead and open Mechanical. So after opening Mechanical, I can see my structure is in my project window. I can come over to my project tree and click on the Geometry tab, and I can see the 20 components that make up my geometry. I can click on different components and they light up, and I can see what component that is. I could also come down now, and in the details of each of these components, I could look at the material assignment, and I could change that material assignment. Here we have structural steel. If I wanted to change it, I'd simply click on that box, click to open the drop-down window, come up and select my different material, and click Enter. If, for example, we decided now that we didn't want to have all of these holes, I can reorient the structure by clicking my middle mouse button. And then to get rid of these holes in this outer race, all I would need to do is come back to Space Claim. I'll reorient this structure by clicking on the X-axis as well. And now Space Claim has some nice select tools. I can come up to the Select drop down and click on using lasso. When I do this, this is essentially a freehand sketch of circles, or of a circle that encompasses all the circles or areas or lines or whatever you're trying to select. and you can select those by using that lasso, and you can see that it looks like they disappeared, but if I rotate this a little bit, I can see those have been selected. I can click on the fill tool and I can fill those. You'll note also that I by accident got this little fillet right here, and it filled that fillet. If I can't live with that, I would need to undo that and do another select. So when using lasso on any of these selection tools, be careful that you actually get what you're looking for and not other components. So now I can also come up and use the polygon select tool, where using polygon I can click and then I just draw lines, and these lines select the various circles, and I can close that. Again, I can rotate it and see what I have selected, and then I can click on the fill tool. Another really nice feature is to come over here and I could, for example, select several of these using the polygon approach again. So I would draw a polygon and I would select several. And now I come over to the selection window and I can see that it's blank. So I need to leave that and go back to structure. Then if I come back to selection, it will calculate the different ways that I can select materials. I can come down here to click on all equal radius cylinders, and you can see that I select all of those circles that I want to get rid of. So then I can come and click the fill tool, and I now have all of those filled. Now I can go back to Ansys Mechanical by clicking on the icon, and I can come up to Geometry, right click on Geometry, scroll down to Update Geometry from Source, and down here it will be Thinking, and I can see the progress. Then it will show me the updated geometry without the holes. My materials I'm going to leave as all structural steel, so no changes there. Coordinate systems are okay. When I go to connections, connections describe the contact between the different components. And in this case we have several contacts because we have several components that are in contact with each other. If I click on a contact region, it will show me the contact body and it will show me the target body. It will also come over here in the details of the contact region and describe the type of contact. For example, this is a bonded. If I click on bonded, I have other options here: no separation, frictionless, rough, and frictional. And so you have different types of contacts that you can select. We will go ahead and leave these as bonded for this particular example, and we will look at connections and contacts in a later tutorial. So to perform a mesh, I'm going to click on Mesh and then click Generate Mesh. You can see it's thinking down there, and it gives me a quick mesh. That's probably not as detailed as I would like. I'd like to have a little more refinement in this outer race. And so what I will do is I'll click on Mesh, then come to Refinement, and then I'll select the faces, not the bodies, but the faces that I'd like to have a refinement on. I'll click this front face, I'll rotate it around and control click the second face. I can also click this face on the inner race and the back side here as well with a control click. Now I can come here and click on selection. It says 4 faces. I'll leave the refinement fairly coarse as a refinement of a 1, and then I'll click Update Mesh and see what that gives me. Again, I can see the overall progress down here, and this mesh is taking some time, so it will be quite a bit thinner. Then I can come up to Mesh, click on the mesh, and that looks like a pretty good mesh for what I'm trying to do. So now I need to come to Static Structural and apply my boundary conditions and my loads. What I'm going to do for my boundary conditions is I'm going to set the displacement on this inner face equal to 0, and then I will apply a moment to the outer edge of the disk. So rotating this and zooming in, scrolling in with my middle mouse roller, I can click on displacement, then I'll click the face tool, and I can rotate this and highlight that face, click Control, rotate it, Control click, and I now have my faces selected. I can come over here to the details of the displacement, click apply. It says I have two faces, and I'm going to set the displacements at all of those equal to 0. So I click on it, 0, enter, 0, enter, and 0, enter. I now have my displacement set. I can see that because I have a displacement on this yellow face of 0, 0, 0. Now I'm ready to put on my load. I'll come up here to the loads, and if I wanted to apply a pressure load or a bearing load or any of these other loads, I click this drop down. But if I'm simply going to apply a force, a moment, or a pressure, I can click on that here, and I'll click on moment. I'll scroll in and select that face, and I'll rotate it around and get the other half with control click, and I now have those two faces selected. I can come down to apply, and it says I have two faces. I'm going to enter this in as a component instead of a vector, so I'll click on vector and click the drop down and click on components, and now I want to make sure that I enter the moment about this x-axis, because I want to rotate about this axis here like this, which is my x-axis. So coming down here, I'll type in 100 Newton meters, and the others I will leave as zeros, and now I can see that I have my moment applied. I'm ready to save my file, so I'll go to File, Save, and I can save my project and make sure that's all saved. And then I'll come back and go to my mechanical and determine what I want to solve for. So under Solution, I'll click Stress, and I'll look for equivalent von Mises stress. Under Deformation, I'll look for total deformation. And now I can come and click the Solve command, and it will go and solve the problem. Once it's solved, I get the total deformation, and I can see the large deformation in the outer ring, and I can see the deformations on these inner components. If I look at the equivalent stress, I can see that there are high stresses in this inner race. I can rotate this around and look at the stresses in other components. If I want to look at the stresses inside of parts, I can come to my geometry, and I can right click on that, and I can hit hide body, and it will hide that particular body. So I can click on several of these by select and then shift click and then right click and hide body, and it will hide those bodies. Again, I'm selecting bodies that are not taking up much viewing space already. So I'll click on that one and then shift click here, right click, and go hide body. And now I can see these bodies here have been taken away, and I can come back to my equivalent stress plot, and I can zoom in and look at the stresses that are generated in that hole by removing the body. And I can do a pretty good inspection of the stresses around that. If I want to look at the displacement, all I need to do is click on deformation, and again I can inspect around holes by removing bodies. I can come back up here and right click again and show all bodies, and then I have my full structure that I can look at the displacements or the stresses and investigate some more. If I'm looking at a particular value and I want to know the stresses at a particular point, I can come up here to probe, and when I click on probe, it gives me the numbers and traces the nodes as I move through the structure, and you can read those numbers that give you the stresses at those particular nodes. If you want to record one and log it, all you need to do is click that, and then it shows you the actual stress or deflection, whatever you're looking at that particular point. And you can do that for multiple points throughout the structure.